This will be our last example for section 2.5 day 1. This is the big one. It's the 6-step process for finding all zeros. And this time the new thing is we are going to write the linear factorization at the end as well. So we start with this equation here, x cubed minus 10x squared plus 44x minus 69. First thing that we're going to do is list all the possible rational zeros. And if you remember from the rational zeros theorem, we take the factors of the constant term, divide them by the factors of the leading term. Nice thing is that the leading term is just a 1, so we don't have to worry about any other factors. Everything is going to be over 1, and that makes our process a little simpler. What we do need to know, though, is what are the factors of the number 69. So we have the ones that I'm aware of are 1 and 1 times 69 is what gets that one. Then 3 times 23 is the other pair. And so we've got these 4 different factors of 69. Listing the possible rational zeros, remember that we are going to do the plus minus list. So we'll do 1 over 1, and then 3 over 1, 23 over 1, and 69 over 1, having the plus minus in there for each one. Now again, this is not the actual list of zeros. This is the list of possible rational zeros. So we're just looking at, we're going to look at our graph and see, does that actually match up? So we're going to graph it now to narrow down the choices. As I graph it, the important stuff, this was a weird graph, so if you graph this one, it might not look quite like that. You have to investigate a little further, but from the window I have here, it looks like 3 is one of our rational zeros, one of our nice zeros. Now we do need to verify that using synthetic division. We need to make sure that that is actually the case. So I'm going to put this into synthetic division. We're using 3 as our k value, and then we put the coefficients of our polynomial up in the box. So list those out, and then we'll get started on the synthetic division process. So bring the 1 down, multiply it by 3, add those together, it's -7, multiply by 3 is -21. Add those together, we get positive 23, and then 3 times 23 is positive 69. So we do in fact have a 0 remainder, and that's really important to have. Once we know that, just remember that this isn't the answer, but it means that when we did the division, what came out from the second step was x squared minus 7x plus 23. And that's good to know. We want to make it, at this point in the process, we want to get down to a quadratic, because now with a quadratic, we can do a number of different things. If it's possible, we might want to try to factor it. We could also use completing the square. There are a couple other methods. If it's a real simple one without the x, we could solve it directly. But when all else fails, we can use the quadratic formula, and that's going to be our next step on this one. So quadratic formula, we have our expression right here. We're going to use that formula to find out the x values, or the zeros in this case. So we'll write out that formula. X equals -b plus minus square root of b squared minus 4 times a times c. Everything over 2a. All right, so that's kind of a mess, but we simplify it down. It gets to 7 plus or minus square root of -43 over 2. That's not real nice. One thing though is we have the negative inside there. We do need to get rid of the negative underneath the square root. It's going to come out as an imaginary, and so we have then 7 plus minus I square root of 43 over 2. Now I like to write the I out in front of the square root, just because then there's not any confusion about whether or not it's underneath the square root. So I would put it out in front here, but it's not a huge important thing. This is going to represent 2 of our zeros for this problem. Now step 5 I have here as list the zeros. The one that we found on the front side with the synthetic division was just 3. That was our rational 0. And then our imaginaries in this case are going to be those 2. So we have 3 total zeros, which makes sense because it's a 3rd degree polynomial. Last thing is to write out the factorization. I've already got the x minus 3 there for this one. This one, I mean, it's not very nice. It doesn't look great, but we just have to list it out as x minus, we'll start with the positive version, 7 plus I squared root of 43 over 2. And then we'll finish with the negative version, x minus 7 minus I squared root of 43 over 2. So it looks terrible, but that's as far as you can really simplify it. There's not a whole lot else we can do. That's just our 6-step process. Now, one thing that is a point of confusion, oftentimes people will say, well, okay, now do I have to FOIL those together and go back to get the original? And the answer to that is no, because we just did the opposite process. So our process here was really factoring, which is the opposite of FOILing. We just had to find zeros and do some other steps in order to get to this point in the process.